The latest space news, including China's Tiangong space station, begins testing solar energy transmission. Rocket Lab picks up NASA's Tropics weather satellite contract and Artemis 1's trek to the moon and back. There's lots to go over this week, so let's get going. This is the space race. The Chinese could be on the verge of a major breakthrough in generating sustainable energy from space. The 2022 China Space Conference ran last week from November 21st to 24th, and among the presentations and workshops typical of the event, the China Academy of Space Technology unveiled a plan to test one of the holy grails of space technology: space-based solar power. This idea has been floating around since 1941, at least, when science fiction writer Isaac Asimov published a short story with a description of a system that would gather solar power in space where there's no atmosphere to block transmission and then beam it down through microwaves to power stations on Earth. Later in the 60s, aerospace engineer Peter Glaser actually designed and patented his own system based on the exact same idea, but the technology of the 60s and 70s just wasn't ready. Since then, engineers have been trying to figure out how to make this a reality. Now it's looking like China might be the first to make a real attempt. CAST's plan is to use the newly finished Tiangong space station as a base of operations for testing of more modern designs of space-based solar power. Yang Hong, the chief designer of the Tiangong space station, made a presentation at the conference where he detailed a plan to use the station's robotic arms to deploy an independently orbiting platform with solar arrays that can be used to test power generation, conversion to a transmissible medium like microwaves or lasers, and transmission to Earth. It's currently believed that only those two methods of transmission are feasible, and both have their drawbacks. Laser transmission uses a beam of light to send gathered solar energy to the destination, which will then convert the beam into usable electricity. This system operates really well in vacuum, and it doesn't interfere with communication signals. But our dense atmosphere can strip some efficiency from the beam or cut it off altogether, not to mention that a poorly managed laser system could cause skin or eye damage. Microwave systems like the ones ASMA have envisioned are more powerful and can't be degraded by our atmosphere. They also can't hurt us, but they require large equipment to send and receive signals and can cause some interference. We know that Xinyang University in northern China has already constructed the first prototype ground tower to test the science behind microwave transmission. It's a 75-meter high steel structure that was completed this summer, which is 3 years ahead of the original schedule. The facility is designed to collect solar energy and convert it into direct current electricity, then convert the DC power into microwaves for transmission through the antenna over a distance of 55 meters. As for where this idea might take them in the future, we know that the Chinese have been researching and designing infrastructure projects in space that can reach 1 kilometer or more in diameter, which is the kind of scale that would be needed to make one of these orbital solar farms truly worthwhile. The first test is slated to start in 2028 and will be a space-based high-voltage transfer and wireless power transmission experiment conducted in low Earth orbit. After that, a second phase is planned. The experiment in a much higher geostationary orbit. From their CAST plans to conduct Phase 3 and 4 of the experiment in 2035 and 2050 respectively, and they will aim for generation quotas of 10 megawatts for Phase 3 and 2 gigawatts for Phase 4. It's pretty clear. But this solar generation plan is a big priority for China. The nation has previously announced targets for carbon neutrality by 2060, and while this plan is going to take a lot of work to succeed, China's already proven they have the drive to get major projects done. NASA has found a partner to finally get their Tropics hurricane tracking satellites into orbit after a very disappointing attempt by former contract holders Astra. NASA announced on November 23 that the relatively small launch service provider Rocket Lab has picked up the contract and will be launching the remaining 4 Tropic satellites on 2 of their reusable Electron rockets no earlier than May 2023, hopefully in time for the 2023 hurricane season. The first 2 satellites were lost in a launch failure back in June when Astra's troubled Rocket 3.3 vehicles suffered a failure. The upper stage shut down too early and the payloads were lost as the rocket tumbled and was lost. Astra had already failed to reach orbit with their rockets several times. By that point, only 2 of Rocket 3.3's first 7 launches had reached orbit successfully. Needless to say, NASA's faith in the company was shaken. The Tropics program is meant to track the increasingly vicious hurricanes that batter the Atlantic coasts every year. Each launch would have put a pair of satellites into inclinations that would allow for overlapping orbits with less than an hour between flyovers. The goal had been to have them up before last year's hurricane season. But NASA has said that the Tropics program can succeed with just 4 satellites, and so they renegotiated Astra's contract to launch equivalent payloads later when their Rocket 4 was ready to make the trip, and then they went looking for someone to finish Tropics. Then NASA decided to go with Rocket Lab, a launch service provider headquartered in Long Beach, California. For those of you thinking that name is familiar, it's because Rocket Lab provided the rocket and kicker stage that launched the Capstone mission, sending a telemetry satellite to map a new orbit around the Moon in late June of this year. The company has had 9 successful missions this year, with a 10th on the way from the Wallops Island Launch Complex in Virginia, which is where Rocket Lab has said they will be launching their 2 Tropics missions from. There's been no word on how much Rocket Lab is getting for this contract, as NASA drew it up under their venture-class acquisition of dedicated and ride-share contract system, which is mostly used to license commercial launch providers for higher-risk payloads. But Astra's contract had been $7.95 million, so it's likely Rocket Lab is getting somewhere near that mark. Sucks for Astra to lose out like this, especially because of a vehicle failure on their part. But it's good to see NASA keeping these sorts of contracts to these smaller companies that could use the experience. Rocket Lab is a solid company. The Space Launch System. On November 16, the Orion capsule and the remaining upper stage of the rocket have performed to a level that has generally met or exceeded NASA's expectations. Now, that's not to say there haven't been some minor tech issues. But given how temperamental the setup for Artemis 1's launch was, this mission's lack of any major issues is allowing NASA's techs to unclench a bit and enjoy some of the testing in space. The first round of system checks occurred on Orion's way to the Moon. The NASA ground team performed several hardware and software checks, making sure to get as much data as possible. The extended Orion solar arrays and used the capsule's reaction control system, its little maneuvering thrusters, to check the array's movement against computer simulations to see if their estimations about the forces they'd be exposed to were correct, and all was good on that front. Then they began calibrating the optical navigation system, which acts as a secondary check to Orion Star Tracker navigation sensors. The optical system uses a series of cameras, which also allowed for some great shots of Earth and the Moon as Orion made its closer passes. Star Tracker itself uses the capsule sensor arrays to track where the vehicle is, using key stars as markers. It's even connected directly into the thrust systems to allow for easier guided navigation. It's here that NASA encountered their first problems along the trip to the Moon. The Star Tracker sensors would automatically reset a couple of times, and while this isn't major, NASA is reportedly still hunting down the sources of this bug. After the navigation checked out, NASA spent the next couple of days adjusting testing communications with the Deep Space Network. They were even able to adjust their systems to improve their speed so they can effectively communicate a single gigabit of data in half the time. Now, on day 3, NASA completed their first spacecraft inspection and mission. Manager Mike Serafin happily reported that the vehicle's performance was exceeding expectations. The inspection involves using Orion's exterior cameras, specifically the ones mounted on the solar array wings, to look over the thermal protection system and ensure the vehicle wasn't damaged by any of the debris in low Earth orbit. Everything was, as previously mentioned, looking great, and so NASA spent the next 2 days testing communications ahead of the lunar flyby and the loss of signal that would come with it. We still don't have a great way of keeping full communications with objects that pass behind the Moon. The Deep Space Network helps, but the Moon still casts a shadow over any signals trying to get around it. So when Orion began its close pass over the Sea of Tranquility, where Apollo 11 landed humans on the Moon for the first time, all NASA could do was wait for about 34 minutes and hope the correction burn worked. But once again, everything went smoothly and the signal was reacquired at about 8 a.m. Eastern Standard Time on November 21st. While it was in blackout, the capsule had used its orbital maneuvering system engine for a quick 2-minute and 30-second burn to get the vehicle set up for its planned burn into a distant retrograde orbit. This orbit is the real key of this mission. It's a long irregular orbit that will allow Orion to make close passes with the Moon and then move back out to a point more than 434,000 kilometers from the Earth, beating the previous record held by the ill-fated Apollo 13, which wandered about 400,000 kilometers from Earth to help them slingshot home after an oxygen tank ruptured, and that's actually why Artemis 1 and 2 will be using this orbit as well. The Orion service module doesn't have the same impulse that the Apollo vehicles did, and so it has to use this wide orbit to save fuel for the eventual return to Earth that is due to have Orion back on December 11th as it splashes into the Pacific Ocean after enduring one of the most intense re-entries we will have ever attempted. The capsule will come in at a steep angle and use the lift of its body to skip off our atmosphere before coming down in a more predictable spot. This method is new for NASA, and while it's supposed to allow for more accurate placement of the capsule splashdown location, it will also subject the vehicle to temperatures of over 2,700 degrees Celsius. All of these tests are designed to ensure that we know as much as we can before sending humans back to the Moon on Artemis 2. The amount NASA has learned already is encouraging, and the performance of the vehicle is very good news for upcoming missions. We'll likely have to wait for the final report on all the bugs discovered during testing, but the news so far showcases a very stable vehicle. Thank you very much for watching. Bye-bye.